Hi everyone, Anthony again, and I want to give you a little heads up of what's going to probably occur on Monday. It looks like some concerning weather, especially in this orange region, and then the yellow that's probably going to expand some. Um, we are looking at a level 3 at a 5 enhanced risk for severe weather in the orange, and a level 2 in the yellow, and a level 1 in the green. This is from the Storm Prediction Center, and they are saying that there's a 30% chance of some really severe weather, 15% chance in yellow. So it's going to be a severe event. And I want to break down what's going on. So we have tomorrow a very potent surface cyclone that's going to form. And this storm is going to give us a line of severe weather down here in going into Texas up into Indiana. And then on the back end, you're going to have a full-fledged blizzard with feet of snow in Wisconsin and Michigan. And this is going to move to the east, and it's going to affect us on Monday. And let's zoom in and see what's going to happen there. We're going to start from the top of the atmosphere and come down and show why all the mechanisms are coming together for a severe event. Let's start at 250 millibars. This is usually where planes, fly. This is where we look for some lift in the atmosphere, and we have this purple right here. And you see this purple, this is called a jet streak. And where the most lift is going to take place, where severe weather could really take off is this area, which is known as the right entrance region of this jet streak. So that's number one. Number two is 500 millibars, and this is really where uh, storms start to take off. We look at this all the time. This is like one of our number one keys to severe weather. And we have what's called another jet streak, but we also have what's called a negatively tilted trough here. And if you see this trough like this, and you see the purple and the blue, which is the most extreme winds, you're looking at it. Looks like it kicks up. And you want to think about a soccer player when he kicks a ball, he starts kicking here and he follows through. And that's going to provide more lift. At 850 millibars, which is even lower, this is usually where our winds take place. 850 millibar winds can mix down to the surface if the conditions are right. And this is a part that's a little concerning when I look at some of the data. We're looking at winds at 850 millibars. Of some areas are saying 80 knots, some areas saying 75 knots. That's about 80 to 85 mile an hour winds. I don't think we're going to have 80 to 85 mile an hour winds, but the potential is there. It just needs to mix down, and the way it mixes down is, the lifting mechanisms we were talking about. At the same time, we need dew points at least in the 50s, and we are looking at 60s down here in the Carolinas, Virginia, high 50s in New Jersey, Pennsylvania. So there's plenty of moisture there. So we have all those lifting parameters, but we need something to lift. And that's where we look at what's called CAPE, convective available potential energy. And when we look at CAPE in a situation like this, we want to look at the areas that have numbers probably over 1,000. And we're seeing 1,000, 2,100 across North Carolina, corridor of 1,500, 1,400, and it continues to move east. Now it dies when it gets to New Jersey and Maryland. Why? Well, timing is part of it. The sun will be setting, but also you have these winds coming off of the ocean and going into New Jersey. So that limits the tornadic threat, but that does not limit, and it might limit the wind threat a bit, but it does not limit the um, uh, extreme wind threat. Sorry. It will limit the extreme wind threat, but not the wind threat. There we go. We're looking at possibly 60 to 70 mile an hour winds with this event. So we have this lift here, and then we also look at, well, spin for a possible tornado. And you are really seeing some numbers that are off the charts here. You're seeing 345 meters squared per second squared, 250, 230 These need to be about 100 for tornado genesis, and so a parcel lifts and it can spin really quickly, and that can give you your tornadoes. So what is it all looking like right now? Well, at this point, we are looking at a messy setup to start, but we're going to have what are called prefrontal supercells before this line comes through. This is our squall line. This is the line that's going to cause the most wind and the most issues. In front of that line, you can sometimes have what's called a prefrontal supercell. If you have something like this in that environment, that will spin, that will create a tornado. But behind it is a long line of strong winds and cold air behind it. So that's what our main issue is going to be. We're going to have the possibility of some prefrontal convection, but we also will have this wall line come through at about, I don't know, 8 to 11 p.m., maybe a little earlier, depending on how the models show. But we're looking at some really bad winds. If we want to look at our possibility of a tornado, it's called the significant tornado parameter. And where is it centering? Well, it's sure centering in North Carolina, Virginia, and South Carolina, a little bit in Pennsylvania. But these things change. And again, I don't think New Jersey is going to get it because of the stable air. So extreme winds. There's a tornado risk, especially down in this area. And I will continue to update because this is an environment that we really don't see very often, especially in this area. And with all the dynamics in play, it's going to be quite impressive. So thank you for listening, and we'll catch up again soon.